texture, an important approach to region description is to quantify its texture content, although no formal definition of texture exists. This descriptor provides measures of properties such as smoothness, coarseness, and regularity. The three principal approaches used in image processing to describe the texture of region are statistical, structural, and spectral. Statistical approach yield characterization of a texture as smooth, coarse, grainy, and so on. Structural techniques deal with arrangement of image primitives such as description of a texture based on regularly spaced parallel lines. Spectral techniques are based on properties of Fourier spectrum and are used primarily to detect global periodicity in an image by identifying high energy narrow peaks in the spectrum. Now here in the diagram we can see first diagram related to different type different types of texture in rock and minerals. Texture of rock depends on how a rock minerals look like and feels. Here the texture is based on the size of crystal grains in the rock. Sometimes they are large, sometimes they are small. So the textures, different types of textures are coarse grained, glossy, fine grained, etc. Here in the second diagram, we can observe different types of leather textures. Leather with smooth, flat grains, grainy, pebbles, and embossed texture we can observe here. In third diagram, there are different types of a texture of fabric. The texture in fabric may be embossed, brocade, denim, printed, twill wave, or terry fabrics. Now we'll see what is statistical texture description method based on spatial frequency. In this movements we will calculate. There are two different types of movement we can calculate. It is depend on the data, which kind of data is given. Either a data is ungrouped data or group data. Now first we will see in the detail what is the meaning of ungrouped data and how to calculate the movements for given data. Now here in the image we can observe 0, 1 and 2 pixel. So three gray levels are there. First is 0, second is 1 and third is 2. The size of image is 4 by 4. 4 rows are there, 4 columns are there. The columns are represented by Y and different rows are represented by X. So for this given image, we can calculate a different movements. This statistical approach is one of the simplest approach for describing the texture is to use the statistical movements of the gray level histogram of an image or a region. Now we'll see mathematical equation for this. It's m of I, j equal to first summation for x, that means rows, and second summation for y, columns. X raised to I, y raised to j, f of xy, where f of xy is the name of image, x are rows, y are column, and I and j represent m of I, j. Now we have to calculate m of 0, 0, that is zeroth moment, m01, m10, m11. first moment, M20, M02 and M22 second moment. We'll use the standard formula of M of ij. Now, if I want to calculate the zeroth moment, M of 00, here I and j both values are 0. Let us put I and j equal to 0 in the given equation. So we will get the equation summation x is starting from 1 to 4 because rows are starting from first row to fourth row. Similarly, columns are starting from first row to the fourth column. X raised to 0 and y raised to 0 because I and j values are 0 into f of xy. Now anything raised to 0 is 1. That's why summation x equal to 1 to 4, summation y equal to 1 to 4, f of xy is nothing but addition of all the pixels which are present in the image. And we are getting it as 15. Similarly, by using the same formula, we can calculate M01. Now, here I is equal to 0 and j is equal to 1. So, x raised to 0 and y raised to 1 f of xy. That's why we are getting y raised to 1 f of xy is equal to 3 plus 2 into 3 plus 3 into 5 plus 4 into 4 equal to 40. Similarly, we can find M10. Now, opposite to previous one, here I value is 1 and j value is 0. That's why the equation will be summation of x equal to 1 to 4, y equal to 1 to 4, x into f of xy. Now here, particular row is multiplied with the pixel value f of xy. That's why we are getting 3 plus 2 into 6 plus 3 into 3 plus 4 into 3 equal to 36. Next, we can calculate m of 1, 1. Now here, I and j both are 1. That's why the equation will be summation x raised to 1, y raised to 1, f of xy. Now here both we need to consider the which row and which column. That's why after adding all these values, we are getting 100. Similarly, we can find it for m of 02. Here I is 0, but j value is 2. That's why the equation will be summation y square f of xy. Now y square, that means particular column square that we have to multiply with the pixel values. After addition, we are getting 124. Similarly, we can find it for m of 20 and m of 22. Now this is about the movement for ungrouped data raw movement. Now we'll see central or mean movement for ungrouped data. The disadvantage of the raw movement is that we can observe when we are finding out the movements, there is large effect of which row and which column that particular pixel is exist. That's why we can calculate central or mean movement here to remove the disadvantage. And the formula for this is mu of pq summation x summation y multiply into x minus x bar raised to p, y minus y bar raised to q, f of xy. Here in the equation, x bar is mean of x, where y bar is mean of y. The mean of x we can calculate by m m10 divided by m00, and y bar is m01 divided by m00. For above problem, we are getting x bar as 36 divided by 15 and y bar as 40 divided by 15. The first moment mu00 is equal to m00. Mu10, that is the mean movement, first mean movement, is equal to m10 minus m10 divided by m00 into m00. That's why the first movement is 0. Similarly, m01 is m01 minus m01 divided by m00 into m00. Again it is 0. Mu11 formula is m11 minus m10 m01 divided by m00. In this way, we can calculate the mean movement of ungrouped data. Ungrouped data, that means only if the image is given, then we can use this formula. Now, the second type movements are grouped for group data movements. Now in this, Z with a random variable denoting gray levels. P of Zi are the frequencies where I is varying from 0, 1, 2, L minus 1. Be the corresponding histogram, where L are number of distinct gray levels. Here, two things are given. One is gray level and second one is the occurrence of particular gray level. Now, if the data is given in this form, then how to calculate the movement? And that is called as a group data. The formula is mu n z is equal to summation of I equal to 0 up to L minus 1 Zi minus m raised to n P of Zi. M is the mean value of Z, that is average gray level. We can calculate M using the formula I equal to 0 to L minus 1 Zi into P of Zi. Here we are getting always mu0 equal to 1 and mu1 is equal to 0. The second moment, that is the variance, is of particular importance in texture description. It is a measure of gray level contrast that can be used to establish descriptors of relative smoothness. The standard deviation sigma z also is used frequently as a measure of texture because values of standard deviation tends to be more instinctive to many people. Third moment, mu3 of z is equal to I is equal to 0 to L minus 1 Zi minus m cube into P of Zi. Third moment, measure of skewness of the histogram, while the fourth moment is a measure of its relative flatness. The fifth and higher moments are not so easily relative to histogram shape, but they do provide further quantitative discrimination of texture content. Now these are about the movements. Now we'll see what is a mean movements for this kind of data. It's a mu1 dash z is equal to summation of I is equal to 0 to L minus 1 Zi minus m dash pz of I divided by mu 0 dash of z. Let us see the example. Calculate first 4 moment, that is mean moments, for given data. Now here Zi is given and P of Zi is given. Zi are different gray levels and P of Zi are the occurrence of particular gray levels. For gray level 5, 4 is the occurrence. For gray level 10, 10 is the occurrence, and so on. So 7 data or 7 gray levels are given are 5, 10, 15, 20, 25, 30 and 35. And for that the different occurrences are given. Now let us calculate the first 4 moment, mean moment. M is equal to 5 plus 10 plus 15 plus 20 plus 25 plus 30 plus 35 divided by 7, because 7 data are given. So it is the average of Zi, that is M equal to 20. Mu and dash of Z is equal to, the standard formula is I equal to 0 to L minus 1 Zi minus M raised to N into P of Zi. Now let us calculate zeroth moment. That's why put N is equal to 0 in the above equation. So my equation will be mu 0 dash of Z is equal to 4 plus 10 plus 20 plus 36 plus 16 plus 12 plus 2. Because anything raised to 0 is 1. So there is no effect of Zi minus M raised to N on this. So it is just the addition of P of Zi. It is equal to 100. That is zeroth moment. The first moment, M1 dash of Z is equal to summation of I is equal to 0 to L minus 1 Zi minus M raised to 1 into P of Zi. For normalization, we are dividing that with the mu 0 dash of Z. So it becomes 5 minus 20 into 4, 10 minus plus 10 minus 20 into 10 plus 15 minus 20 into 20 plus 20 minus 20 into 36 plus 25 minus 20 into 16 plus 30 minus 20 into 12 plus 35 minus 20 minus into 2 whole divided with 100. So we are subtracting M value from each value and multiplying that with P of Zi. So we are getting the first moment mu 1 dash of Z is equal to minus 0.3. Similarly, let us calculate second moment by putting the value n is equal to 2. To get m2 dash of Z is equal to summation I is equal to 0 to L minus 1 Zi minus M raised to 2 f of Zi divided by mu 0 dash of Z. After calculating this, we are getting a value 44.5. Now let us calculate third moment mu 3 dash of Z using the same formula just by putting n is equal to 3. So mu 3 dash of Z, we are getting minus 52.5. Similarly, by putting n is equal to 4, we are getting mu 4 dash of Z, it is equal to 5462.5. Now this is about moment Now let us see what is mean movement. Mean movement. The first moment mu1z is equal to 0. The formula to find a second mean movement is mu2z is equal to mu2 dash z minus mu1 square, mu1 dash square. Now we have already calculated mu1 dash and mu2 dash of z. So it is 44.5 minus 0.09, and this is nothing but mu2 of z is equal to 44.41, that is sigma square. Third mean moment formula is mu3z is equal to mu3 dash minus 3 mu2 dash mu1 dash plus 2 mu1 dash raised to 3. Just by putting the values of mu3 dash, mu1 dash and mu2 dash in the given equation, it is minus 52.5 plus 40.05 minus 0.054. It is equal to minus 12.504. Similarly, the fourth mean moment formula is mu4z is equal to mu4 dash of z minus 4 mu3 dash of z mu1 dash of z plus sigma mu2 dash of mu1 dash square minus 3 mu1 dash raised to 4. It is equal to 5423.5057. In this way, we have calculated all four mean moments mu1 of z, mu2 of z, mu3 of z and mu4 of z. Now here two more examples are given when mu1 dash, mu2 dash, mu3 dash and mu4 dash are given as 1, 10, 20 and 25 respectively. Find the moments about mean. Third example is given. 5 datas are given. In this the pixel values are 2, 3, 4, 5 and 6, whereas the occurrences are 1, 3, 7, 3, 1 respectively. Find all 4 moments about the mean. Thank you.